Jai Hind, dear students. I am Dr. Preeti, and today we are going to have the second class for the revision of gravitation chapter. Okay, so in the previous video, we have discussed some of the topics from gravitation, that how G is there, what is acceleration due to gravity, what is the universal law of gravitation, and today we are going to have a look about these points. So, starting with the first point, that is mass and weight. In your exams, the question that is asked usually is based on the difference between mass and weight. So let's start with that. Mass of an object is the measure of inertia of an object. More the inertia, more will be the mass of an object. But do you know that mass is measured in kg and mass remains same everywhere? That is, even if you go in the space, your mass will be the same. Even if you go on moon or on any place on earth, the mass of an object will not vary from place to place because it is independent of acceleration due to gravity. So the mass of an object remains constant whether the person is in space or on any planet. The mass is going to remain the same. Next, if we talk about weight, every time till today, whenever we talk about weight, we always talk about weight, that a person's weight is 50 kg or something like that. I want tomatoes, I want 50 kg tomatoes. So we talk that weight of is measured in kg. But today your concepts are going to be shaken because weight is not measured in kg. Your weight, if you say your weight is 50 kg, it's not 50 kg actually, it is in newtons. Your weight, when you are standing on a weighing balance, the weight of a person is shown by the weighing balance, and if your weight comes out to be 50 kg on a weighing scale, it measures 50 kg, that means actually your weight is 50 newton. And what is your mass then? Let's find out. Weight is the measure of the force with which an object is attracted towards the earth or any other planet. So suppose we talk about us on earth, then the force with which we are attracted towards the earth is mass of a person multiplied by acceleration due to gravity. From where we got this formula? It is from the same formula that we have seen in force and laws of motion. Force is equals to mass into acceleration. But now here acceleration is acceleration due to gravity when we are talking about earth. So the weight force is the mass multiplied by acceleration due to gravity. It is the force with which a person is being attracted towards earth, and force with which a person is attracted towards the earth or any other planet is equal to the weight. So weight is equal to mass into gravity. So this weight is going to change from one place to another. The weight of a person on earth will be different from the weight of a person on moon, and it will be again different from the weight of the person in space. That is why in space the astronauts feel weightlessness, because in space the acceleration of due to gravity becomes minimal or almost zero. Then they feel weightlessness because their weight, anything multiplied by zero, will become zero, so the weight becomes zero. Similarly on moon also, the weight of a person on moon will be 1/6 of the weight of a person on earth. This is because the weight of a person on moon will be less because the moon has a lesser acceleration due to gravity. Its mass is less, and so the value of small g, that is acceleration due to gravity, is also less on moon. And so the mass of or the weight of a person on moon will be 1/6 of its weight on earth. So suppose your weight is 60 Newton on Earth, then your weight on Moon will be just 1/6 of 60, that is just 10 Newton. And that is why you must have seen that when the astronauts are just moving on moon in the, like in movies, or sometimes you must have seen that just hover around. They are not just actually they are not feeling that weight of that costume and weight of their body. They just feel as if they are floating on water, floating on air. So that is because of that reduced weight on in space or on moon. Okay, now when you have to write, I told you that you have to write the differences. So when you have to write the differences, what you will say that mass of a person is the measure of inertia is there. Okay, then weight of a person is the measure of the force with which a person is attracted towards the earth. This mass of a person is independent of acceleration due to gravity, and it remains same at every place on wherever you go in the universe. The mass will be remaining the same, but the weight of a person varies from place to place. The weight of a person is different on the moon or on space or on earth. Okay, the SI unit of mass is kg, and the SI unit of weight is same as that of force, that is Newton. So your weighing scale is showing your weight to be 50 or 60 kg. That is actually your weight is 60 Newton. And if it's your weight is 60 Newton, then what is your mass? Mass will be equal to weight divided by acceleration due to gravity. So if your weight is coming out to be 60 Newton, so your mass is just 6 kg. Only 6 kg is your mass. But when you are standing on a weighing scale, that is actually depicting your weight, and that is actually 60 newtons. Fine? Okay. Now let's move on. So that is about the mass and weight of a person. Okay. Now one question is there in NCRT book based on that. That if a person purchases some gold on equator, on poles, and then goes on equator, then what will be the effect of that weight on equator? So you all know, I hope you remember that the earth is not exactly spherical. It is somewhat oval in shape, and so the radius of the earth radius of the earth at equator is more. Radius of the earth at equator is more as compared to the radius of the earth at poles. And radius and acceleration due to gravity are inversely proportional to each other, so the gravitational pull at poles will be more as compared to that on equator. Since gravitational pull on poles is more, then the weight of the person will also be more at poles as compared to the weight on earth, on equator. So if you purchase some gold at equator, there the weight will be shown more. But if you measure the same gold at equator, you will find that the weight of that gold is less. You will feel that you have been cheated. You have been given lesser amount of gold, but it's all because of acceleration due to gravity. So is it wiser to purchase gold from areas near equator? Okay, so that is all. Next, moving on to the concept of thirst and pressure. Okay, what is thirst? Thirst is the force applied perpendicularly to any surface. That is thirst. Okay, so thirst is like same as force only. When you are applying the force perpendicularly on any object, that is known as thirst. Since thirst and force are interchangeable, it is a measure of force. That is why thirst is having the same SI unit as that of force. The SI unit of thirst is also Newton. SI unit of force is Newton, weight is also Newton, and thirst is also Newton. Then what is pressure? Pressure is the thrust applied or force applied per unit area. So what is pressure? Pressure is the force applied per unit area or thrust applied per unit area. Fine. So the pressure is what will be the SI unit of pressure? What is the SI unit of force? It's Newton, and divided by area, that is Newton per meter square. that is also known as Pascal and represented by Pa. Okay, so the SI unit of pressure is Pascal. Now, based on this thrust and pressure, you can have many logical based questions. For example, you must have seen that the soldiers are having the tankers, and the tankers are having the wheels, and that the wheels are covered with long chains. So when they are moving in desert area, or whenever they are moving on the land that is not having very well constructed roads, still they are able to manage with that, because the wheels are covered with chains. So when they are moving, it is all their weight is coming on these chains. The weight is getting distributed over a large area, and that is why they are able to move on that uneven ground or on the desert area. If we try to move on the desert area, just suppose we try to move on a desert area with your bicycle or with your bike, it really becomes difficult. But if you observe the soldiers moving on the desert area with these tanks are having a lot of weight. They are really very very heavy, but still they are able to move because that weight is distributed over a large area, and so the pressure applied by that tank will be less. Okay, so when the area is more, the pressure is less, and so to decrease the pressure, we have the wheels that are covered with chains in the tankers. Okay, so similarly, when you are constructing a building, you need to have a very broad foundation. The foundation of that building is laid in such a way that it is having a broad foundation, so that it doesn't puts a lot of pressure on the earth, and it doesn't goes into the earth. Okay, but apart from that, if you talk about something opposite of that, for example, cutting edges of knife. So when you have to cut something with a knife, you are not going to use the blunt end of that. You are going to have the sharp end of it moving into that if you want to slice an apple or something. So you are cutting it with the sharp end. So why sharp end? The pressure will be more, because that same force is now applied over a small area. So smaller the area, more will be the pressure. Okay, similarly, you can try it on your own right now itself, that if you just try to push your cheek with your hand, you will not feel any pressure. But if you try to push your cheek with the tip of your finger, you will really start having some pain because you will feel that pressure. Okay, so logical based questions are usually asked from this topic. That like one more example is why the cars have a broader tires as compared to your cycle. So cars have broader tires because the weight is distributed over a large area, and so the pressure exerted will be less. If the pressure is distributed, if the pressure is less, then the car will be able to move safely on the roads. But if it is having very thin tires as that of your cycle, then it will not be able to bear so much weight that will be cutting into the roads. Okay, so that is the reason behind broad tires of heavy vehicles like trucks, cars, and all. Okay, so that is the concept of thirst and pressure. Fine. Next comes the pressure in fluids. But before that, what are fluids can come as a 1 marks question. That what are fluids? So fluids not only includes liquids as well as gases that can flow, that are fluids. So, whenever we have any fluid in a container, for example, if we have a bottle filled with water, then this water will be applying pressure on the walls as well as the bottom of that bottle. Okay, so the liquids or fluids always apply pressure in the container in which they are filled, and they apply pressure on the walls as well as the bottom of that container. Okay, so that is about pressure in fluids. Next comes the concept of buoyancy. You must have observed that if someone is there swimming with you, then you can lift that person very easily in a swimming pool, but not so on the land. If you haven't tried that, just try it next time. If you are in a swimming pool with your sibling or anyone else, just try to lift that person in the swimming pool. It will be really very easy for you to do that as compared to doing the same thing on land, because buoyancy is supporting you. What is buoyancy? Whenever any object is immersed in water or any other liquid, suppose this is an object that is put in water or any other liquid, then the water or that liquid tries to apply an upward force, upward thrust on that particular object and tries to push that object out of water or that fluid. This upward force is only known as buoyancy or buoyant force. Okay, so the force applied by any fluid, it is the upward force applied by any fluid on any object immersed partially or fully. You can immerse that object fully or even partially. Then also the buoyant force will be applied on that object, and this force applied in the upward direction is known as buoyant force, and this concept is known as buoyancy. This tendency of applying the force in the upward direction by any fluids is known as buoyancy. Okay, so because of this only, the weight of a person will be appearing to be less as compared to that on earth. In what if you are weighing something, that weight will be less as compared to the weight of that particular thing on land. Fine, because here the upward force is there that is pushing that object in the upward direction. So whenever an object is there in water, two forces are acting on it. What are the two forces? The weight of a person, that is equal to mass into gravity, acceleration due to gravity, that is pulling the object towards the earth, that is pulling the object in the downward direction, and this buoyant force will be pushing the object in the upward direction. So the buoyant force will be applied in the upward direction, and the weight of an object, that is equal to mass into gravity, that will be pulling the object in the downward direction. So if the weight of the object is more, then the object will sink into water, but if the buoyant force is more, then the object will be floating on that particular fluid. So if the buoyant force is more, if this is going, it's like a tug of war going on between weight and buoyant force. On one side the weight is pulling it down, on the other side the buoyant force is pushing it upwards. So whoever is the winner, the object is going to move towards that side. If the buoyant force is the winner, if the buoyant force is more as compared to the weight of the object, that object is going to float. But if the weight of the object is more as compared to the buoyant force, then the object is going to sink in that particular fluid. Okay, actually buoyancy also depends on density. So whenever we have to define something that's going to float or sink, we usually do it on the base of density also. That if the density of an object is more than that of the fluid, it's going to sink. And if the density of an object is less, then the object is going to float. If the object is lighter, it's having less density like cotton, it's going to float on water. But if it's having a lot of density, if it is like a piece of iron, then it's going to sink into water because its density is more than that of water. So we can define sink and float on the base of density as well as on the comparison of buoyant force and weight of an object. And actually this buoyant force also depends on the density of something. Okay, so if you are having a denser fluid, the buoyant force will be more. The buoyant force is directly proportional to the density of any fluid. So if you take a denser fluid, that will be applying more upward force, that will be applying more buoyant force. If you have a less denser fluid, then that object will be applying lesser force, that will be there. Okay, So I hope what you all need to remember from this topic, quickly we'll revise buoyancy. Buoyancy is the upward force applied on any object that is immersed partially or fully in water or any other liquid. This upward force is known as buoyant force. Now, buoyant force always pushes an object in the upward direction. Weight of an object always pulls it in the downward direction. So, whoever is the winner, if the buoyant force is more, then object is going to float. If the weight of an object is more, then it is going to sink into water. Okay, I hope that is clear to everyone. Now we will move to Archimedes principle. That is a beautiful principle by which you can construct a ship, by which you can devise many things in life. Okay. For example, I'll tell you. Suppose you are an engineer and you have to construct a ship. So you have constructed a beautiful ship, but you should know how much weight your ship can carry. You should be aware that you can carry how many passengers and what could be the total weight that your ship will be able to carry. How will you find it out? Will you try to put some weight on that and then calculate it? Huh? Are you going to do that? That suppose this is your ship that you have constructed. So this is water body, whatever it is. So how you are going to measure how much weight your ship can carry? So are you going to do like that? That you are going to ask people to just go into your ship and you will find that how this much weight could be bared by my ship, and if I put that more than that weight, then my ship is going to float. You are going to check by putting weight into your ship? No, you are not going to do like that. You can easily calculate how much weight your ship can bear by calculating the buoyant force. Okay, because if buoyant force is more, then the object is going to float on water, and you want your ship to be floating on water and not sinking in water. So the buoyant force should be more as compared to the weight of the ship. So how you are going to measure this buoyant force? That is by using Archimedes principle. Okay, Archimedes was a scientist and he told that the buoyant force applied by an object and is the upward force when it is immersed partially or fully in water, and that is equal to the weight of the fluid displaced by that particular object. Now, how will you measure buoyant force? Buoyant force it could be measured by using Archimedes principle. And what is Archimedes principle? According to Archimedes principle, the upward force exerted on any object, which we call it as buoyant force, this upward force is equal to the weight of the fluid displaced by that particular object. Now, what does that mean? Suppose this is a water body and you have your, before putting your ship into that, just measure the volume of water. Okay, suppose this is having the readings. Okay, suppose this is 100 ml, 100 liters. 100 liters of water is there in this particular container. Okay, now when you put your ship into that, you all know that the water will be displaced, the water will be coming up the level. Okay, you must have observed that when you go into a bathtub, then the water level comes up. Okay, so when you put your ship into that, that water level is going to come up. Now suppose it comes to a level of 101. After putting your ship into water, the level of water rises by 1 liter. Then just measure the weight of 1 liter of water. That will be equal to the buoyant force applied on your ship. Okay, so the buoyant force will be equal to weight of the fluid displaced by that particular object. Okay, so if the volume of the water displaced is more, then the upward force, that is buoyant force, will also be more. If you want to increase this buoyant force, you have to increase the fluid, the amount of fluid that is displaced by that particular ship or by that particular object. So more the water displaced, more will be the buoyant force. Okay. To sum up, once again, I'm telling you that the Archimedes principle states that the upward force is exerted on any object immersed partially or fully in it, and this upward force is equal to the weight of the fluid displaced by that particular object. Okay. I hope you are able to understand that. Okay. So by that way, you can construct your ships, your submarines, all could be constructed by calculating what is the buoyant force, because you want your ship to be floating, so you want the buoyant force to be more. Based on this only, one very frequently asked question is there: why does a sheet of iron sinks into water, whereas a ship made of same iron floats on it? A ship made of iron only floats on water because it displaces a large volume of water, and the volume of water displaced will be directly proportional to the buoyant force. जितना ज्यादा पानी वो डिस्प्लेस करेगी उस पर उतना ही ज्यादा buoyant force अप्लाई होगा, and जितना ज्यादा buoyant force अप्लाई होगा, then that will be the weight bearing capacity of the ship. Okay, so that is why a ship floats on water, whereas a sheet of iron that is not displacing much water, that is going to sink into water. I hope that is clear to you all. Okay, now the applications of Archimedes principle. Applications of Archimedes principle is in the construction of ships, submarines. Apart from that, based on this Archimedes principle only, we construct lactometers, which measure the purity of milk. How does they measure the purity of milk? By calculating its density only. Okay, so they measure the purity of milk. Apart from that, hydrometers are there. Hydrometers can measure the density of any fluid that you want. Okay, so if you want to measure the density of honey or any other fluid, that could be done by hydrometers. Okay, so hydrometers, lactometers, construction of ships and submarines, they are all based on the Archimedes principles. So they are the applications of Archimedes principle. Very frequently asked question in your exams: write the applications of Archimedes principle. Okay, so I hope that is all clear to you all. One last very interesting question based on these topics is, uh, you must have asked that question to each other when you in your childhood, और आपने देखा होगा बच्चे एक दूसरे से पूछते हैं या आपसे पूछते हैं कि 1 किलो रुई ज्यादा भारी होगी या 1 किलो गोल्ड और 1 किलो आयरन, है ना? एंड यू ऑलवेज से बोथ आर 1 kg only, so they are going to measure the same. Both will be having the same weight because both are 1 kg. But actually, it's not the same. If we talk about कि कौन ज्यादा भारी है, which one is heavier? If we talk about 50 kg of cotton or 50 kg iron piece, then which one is heavier? Actually, if both are measuring the same on weighing scale, still one of them is heavier. Okay, and you are going to guess it on your own. Just let me know. अगर आप सोच रहे हो कि दोनों में से आयरन ज्यादा भारी होगा, then you are wrong. It's the cotton that is going to be heavier. Cotton, 1 kg of cotton is heavier as compared to 1 kg of iron. Why is it so? Because buoyant force is not only in liquids, that is in fluids. So buoyant force is also applied by the air. तो अगर एक 1 kg of cotton is there and you have 1 kg of iron weight with you, then the buoyant force will be more on the cotton because it is displacing a lot of air. And whenever any object displaces the air or any fluid, that fluid is going to put an upward force. So this cotton will be experiencing more upward force And so the weight on the weighing scale that is shown by cotton, it's actually that cotton is heavier as compared to the iron piece, because that iron piece is exerting is experiencing lesser buoyant force as compared to the cotton. Okay, so to your surprise, the answer is the cotton piece will be heavier. 1 kg of cotton or 100 kg of cotton, as given in your book, 100 kg of cotton is heavier as compared to 100 kg of iron, because the buoyant force, the upward force that is experienced by that cotton is more as compared to the iron. Okay, so on iron, that's only the mass into gravity that is being shown when you measure it on a iron on a weighing scale. But when you measure something on an iron scale that is cotton, then the mg, that is the weight of an object, is pulling it in the downward direction, but the buoyant force, which is really considerable in case of cotton, that is pushing it upward. So the net force that is being shown on the weighing balance will be lesser as for that of cotton. Okay, so I hope you are able to understand the topic. That's all for today. In the next class, we are going to discuss all the NCRT questions from your gravitation chapter. Okay, do let me know about your queries in the comment section. I would be happy to help you out. That's all for today. Good day, everyone.